now. All right. So the way to make vectors easy is to do everything in component form. So we can turn anything in component form. So the objective today is going to be, first of all, we'll start off with finding component form given magnitude and direction. And some of you are probably saying, oh, well, that's exactly what we did last week. When you're right, but we did it, we found it numerically. But we're gonna extend that today. All right, and then we'll do a second objective, which is the lesson, and that's it. We'll move on. So we need to take a look at this picture, because I could just give you a formula, but once again, it's got to make sense. You know, if we have a cold day on Wednesday or something, you got to be able to remember what's going on when you come back. It's not going to happen, but whatever. Looking at a picture, that main focus, I'm going to delete it, but I'm going to highlight it for the video. The main focus is that vector right there. That's what we're looking at. All those dashed lines, they're just for to get your bearings, to see where everything is. So let me get rid of that dashed line. So let's focus on that main vector. And that main vector, one more time, I'll highlight it and then get rid of it. That main vector has a magnitude, which is a fancy way of saying length. And it also has a direction. So that's everything we've done last week. So I'm just refreshing you. So magnitude and direction. So let's look at the picture and then put some things together and then do an example, and hopefully all the pieces will fit together nicely. So the component form of that vector is that xy. It's that horizontal component and that vertical component. So it has to travel this far left and right, and in this case right, and it has to travel this far up in this case. So everything works out to be very simple 8th grade SOHCAHTOA. So let's just go ahead and use that. So we can all see that the vector is the hypotenuse of the triangle. Agreed? Don't ever forget that. So that means it's going to be how far the change in x over the change and the change in y. So let's write that as trig now. Let's go back to freshman year. So cosine of an angle is equal to its adjacent over its hypotenuse. So let's take it one level over. So now let's rewrite that same statement, but let's call it cosine of an angle is equal to the adjacent, which is known as the horizontal component. Right, this right here I'm pointing to, that x is the horizontal component, divided by the radius of the triangle there, the hypotenuse of the triangle, which happens to be the length of the vector, the magnitude of the vector. I put it in like little absolute value bars there. So we've used freshman year to look at a vector, but just we've named the parts differently. That's the only thing we've done. So now let's go ahead and reorganize that and isolate the x. So I'm going to change the color, and I'm going to multiply both sides through by r. Actually, I'll do a different color because I don't want it to be the same as the drawing. So that means I multiply the r up to that side, multiply by the cosine of the angle, gives me my x value. So now that says you've done it, everything's done. If I want my x, I have to type in r cosine theta. I have to type in the length of my vector multiplied by the cosine of its angle. And then let's redo the same thing, but let's do that in sine. So sine of theta from freshman year or 8th grade, whenever it happened to be, is opposite over hypotenuse. So let's look at that with the pieces of triangle we're seeing over here. So that's opposite is y over r. So my y coordinate is r times sine of theta. All right, so let's change a different highlighter so we can see that we've reached a point that we need to be. Now that's not good because we're going to have there. All right, the lesson so far, you don't have to reiterate, you don't have to prove to me all of the stuff that just happened. You have to remember these two things absolutely positively. Just walked in. This is like the secret to vectors today, right? So if you know x is found by r cosine theta, and you know y is found by r sine theta, you have all the tricks you need. That's it. All right, so that's super. That's where that comes from. Objective 2. Okay, so objective 2, we're going to solve a triangle problem using only vectors. And this, you'll get so good at this, you'll never have to pick up a pencil and paper. It's just so easy. All right, so let's go ahead and put a few buzzwords so I don't have to write the whole problem. Okay, so let's do, we're going to have a problem, and it's going to involve an airplane. So you got an airplane. And in this problem, it's going to be traveling miles. Sometimes you'll have speeds, sometimes you'll have forces, so on and so forth. In this problem, we've got an airplane that's traveling 260 miles in a direction of, let's do this in confusing language now, because that's where we will learn things. We are 20 degrees west of north. Sometimes that's written north 20 degrees west. This is not an aviation class or a guidance class. We don't need, you can always ask me and I'll say that means 20 degrees west of north. That's what I'll say. I'll just repeat it back to you. Like if I give you this. So don't worry about that. But what you do have to do is build the diagram. And I'll show you that in a minute. Okay, so that's direction 1. Direction 2, you're told that once they reach that 260 miles, they are going to the same airplane is going to travel 400 miles in a direction. I don't even know why I need that comma there. In direction of 80 degrees west of south. However it's written. Sometimes I might say 100 degrees clockwise from north. Like, you just have to be able to read it and draw it out. But we can work on that. I can give you some, you bring me a diagram and I'll say, what have you drawn? What have you seen? Like, maybe let's read the words and point to it, and then we'll work our way through it. But just be able to build a diagram. The question to all of this problem, here's the question. How and what direction is the airplane from the starting point? All right, so let's try, and it kind of messes my pen up a little bit, but I'm going to try and shrink that so we keep all the words up there, and I'm going to draw it out. So let's see if I can do that. Let's see. This does kind of... All right. I'm going to draw it up here. So I'll keep this little zone for drawing. So, airplane takes off and it flies 20 degrees west of north. So let's see. Let's draw everything. I'm going to refresh you from the weekend. Remember, wherever I move, wherever I am, there's always an X, Y through my head. There's always a north, east, south, and west through my head. Always, wherever I move. Right? So here's the airplane where it starts. Right there. And it flies 20 degrees west of north. And since north is right here, it's flying like that. I'll do it a little bit longer. I don't want to get... Yeah, I'm not going to do... I could make it bigger, but I don't want to run off the screen because I want to keep it reasonably to scale. So, and it flies in that direction for, what did I say, 260 miles? Yeah, the first plane. And this little angle right here, right there, is 20 degrees. It's 20 degrees west of north. Then the airplane turns. It turns to a direction of 80 degrees west of south. So let me put the airplane is now here. So let me put little northeast, south, and west through it again. All right. And then it's going to move 80 degrees west of south. So some people might call that 10 degrees below 10 degrees below west there, but it was whatever. That's what I've said. And they fly for 400 miles. I tried to do it a little bit longer. And the question is asking, how far and what direction is it? So we want to know the length of that, and we want to know the direction angle that that vector's traveling. So let me pull that vector off and write it above it. So actually, I'll do that. I'll write it below it. So the actual vector with all the other drawings taken away is this final vector. Whoops. Hard to do. Right there. That's the final vector we're analyzing. And it I don't know what just happened. And it has a horizontal. I do it in a different color. It has a vertical and a horizontal component. So this location in space is a vector. That vector component is xy. So I'm going to leave actually I can probably bring it up here so I can talk, but I want to go up to the board and point to stuff because I can't really do it with a... So this is your biggest thing that you need to get set up. The original diagram of what's going on, right? Marking out everything that's there. After you've done it a time or two, you'll just be able to think about it. But I highly advise any assessment that goes in the grade book, I always give you a ton of time. Just sketch it out, make sure you don't make any silly mistakes, right? Get this built. So now it's a triangle. So we're going to use vectors to do that. So I'm going to enlarge this, and I want you to see with me. All right? So this this right here, that xy, that's where we were, that xy right there, that is the sum of, see, the first vector traveled from here to here horizontally. You see that? Right? It traveled that far horizontally. So look, for that vector traveled that far horizontally. And the second vector traveled that far horizontally. So our resultant vector that starts at the beginning to the end is the sum, the addition of the components. So it's this x coordinate added to this x coordinate. And even if they were going in opposite directions, if I'm pushing something at 10 newtons towards Caleb and he pushes it back at me at 15 newtons, which direction is it going? Is it going towards me or away from? Is it going back at me or towards? If I'm pushing 10 and he's pushing exactly, then it's coming back at me at 5 newtons because I'm dampening his force by 10, but the resultant is 5. So it won't matter if it's plus or minus. Okay, so please don't jump ahead of me on this one because I've got lots of tricks to show you, right? There's lots of tricks, and I'll show them one time. It's big and slow. So the horizontal components added together, and the y's are going to be the same thing. Oh, here's a good way to show it. So the first one, let's do this in like that color. So the first vector traveled up that amount, and then the second vector went down that amount. So the ultimate y is all of the positive plus the negative. And the positive y, just answer me a question. Is your answer, see, if I go up that much, but I go down that much, is the ultimate answer going to be above the x-axis or below it? Above it, because my force up is stronger than my force down. All right, so let's go back here. So now all we've got to do to find that resultant vector, this xy right here is going to be the sum of x1's vectors, the horizontal component from the first vector, plus the component from the second, comma, y component from the first, y component from the second. That's all we have to do. Then I'm going to go over to the computer and do that. And I'm going to have to come off of this screen. But what I did do is if you get lost, I put a video of the calculator keystrokes online already. So this video will be uploaded, and then right next to it will be the calculator instructions, because I can't get the calculator on this, right? Because I don't have a license for this one. But on that I do. So I'll put that up. But and we'll do it together. But what's going to happen is eventually we're going to get that x and that y, and then I'm going to ask you, well, actually, I've already asked you. I've asked you, how long is it? Well, once you know the x and the y, what 8th grade theorem, whose theorem can help me find the hypotenuse of a triangle if I know the legs? Pythagoras. So we're going to use Pythagoras' theorem to find this fancy magnitude of the vector. Magnitude of the vector is just the hypotenuse. Right? So we're going to use Pythagoras' theorem to find the magnitude. And then I want to find direction angle. Go back to SOHCAHTOA. And I use my inverse tangent. And then we do it. Okay? All right. That's anything before I change computers? Okay. All right. All right. Everyone grab calculators. Make sure you're with me. I know it's 7th. Yes. That one works. Okay, now, different classes. I've got different classes and different things. So check, if you borrowed one of mine, make sure you're in degrees, and make sure you're also in function mode. So go in your mode, and if it looks like if all the weirdness if your Y editor looks normal, hit your Y editor. Yeah, you look fine. If your Y editor looks normal, don't worry about it. If your Y editor looks weird, talk to me. Right? Does everyone's Y look okay? Yeah, okay. Degree. Degree, because I gave you the question in degree. If I gave it to you in radian, you'd be in radian. Okay, so I'm going to go over to the other computer. So let's do this. Okay, so I heard the question. I'm going to answer it. What we're finding, the first thing we're going to find, that's good. The first thing we're going to find is the component form. We're going to find the X and the Y of that vector. That big red vector bulb, the messy one, that is what we're finding. And we're going to find that by adding the two vectors, the X's from the both vectors. And then I'm going to add the Y's from the both vectors. All right, so here we go. So ask during this because you'll help people on the video. Plus, this is like the only dry run we'll get. All right? So remember, X is R times cosine theta. Repeat after me. X is R times cosine theta. All right. So here we go. So the first vector was 260 units long. So that's your R. That's the length of the vector. Multiplied by the cosine of the angle. The answer, do not put 20 in there. It's 20 degrees. I've got to go back over here one more time. Oh, I'm still over there, aren't I? I haven't done, okay, that's good because I haven't changed. All right, so I'm here. I'm 20 degrees west of north. So most people, so in math, we call that 90, 110. We call that 110 degrees, right? So in math class, we'll call that 110 degrees. We'll turn everything to the scale. And that's good because I forgot to put it on computer. Okay, so we type in 260 cosine of 110. Okay, it's the time to ask the question why it's 110. Is everyone good with why 110? It's 20 degrees beyond the vertical. So let's look at it one more time. So here we go. Right there. See the vertical right here? It's traveling 20 degrees west of north. So 20 degrees beyond north. So 20 degrees to the left of 90. So that's 110. Is that okay? Yay, nay, or just talk later? Is that you? I'm waiting for you. I don't want to say your name.
No, it's fine.
You're good? Okay. So we'll did it make sense? Or well, if not, make sure we talk later. 260 cosine 110 plus the other vector, it's 400. Before I go back to the computer, 400 times the cosine of its angle. And its angle is, if this is 80 degrees, help me out. If that's 80 degrees, what must this angle right here be?
190.
No, that's the answer. Let me ask you one more time. So if that's 10 degrees, right? And then your answer is, if I travel 180 plus another 10, that's 190. So exactly. So I'm going to do 400. Did I say it was 400? Yeah. Okay. 400 cosine of 190. Did it come up yet? Yes. All right. Hit enter. So what does that mean? Does that mean the plane is 482 miles to the left or to the right? To the left. Perfect. So you're getting your bearings. Keep that in mind. So you know the tangent, anytime you're left, you're going to be lied to. So that's good. That's good to know that. Okay, now here are all the calculator tricks. Ready? So go down to, see where my mouse is bouncing around, right here by this STO button. It's right above the on button, right? Hit store, and it'll put whatever your answer is, store it in, since it's my horizontal component, let's store it in the variable X. Don't worry about this. It won't change this thing at all. That'll be fine. David, you okay? You need a drink? You good? So store it as X. All right. So what this means is, look, anytime I hit X now, it's going to tell me X is negative 482. So if I wanted to know what 2 times X was, I'd put 2 times X, and it would tell me what 2 times X is. Right? Doesn't matter. So that's good. So it's stored now. Now, now your second time-saving tip, go to your original function. So go up, 2, 3, 4. Go to that and hit enter. Now, go and change the cosines to sines. Because you're doing, it's going to be r cosine theta, r sine theta. So you might as well just use the same statement. Oh, whoops. It's a bit slow for me on this computer, but once you do it in your hand, it's so easy. All right, so I'm going to come back. So I'm going to come over here. Okay, there we go. So I put sine, and then I'm going to go 1, 2, 3, 4, 5, 6, 7, 8. And I'm going to change that to sine. And then, of course, now that's my vertical component. That's my y. So I want to head and store that. So go to my STO, store as y. Now, y is a little bit trickier, but it's your 1 key. And it's green. So you got to use your alpha menu, alpha 1, store it as Y. You've got the whole alphabet. We could store, tons of things. Store it as Y. Comes in very handy. So now I've got my X and my Y stored. So if I accidentally clear the screen, I hit it. For some reason, it's lagging. Uh-oh. Uh-oh. All right, well. Okay, let's forget it. It's now frozen. Oh. Ah. All right. I'm going to... Do I wait or do I ditch it? I'm going to ditch it. All right. It's crashed this thing twice. Okay, so I'm gonna, all right, you've got it all in your calculator. Mine's crashed. All right. So I want you to do this. So I want you to clear all your home screen, just clear. And then I ask you, how far right or left did you go? So you hit X, enter. So hit X, enter, and then you should have the negative 480 on. And then I'll say, how far up did you go? So you hit your Y, and that'll have your 170 odd, right? Okay. Now, I would normally have that on the calculator, but I'm going to go over to this. So go ahead and clear the screen so it's nice and fresh. So now, to find the magnitude of that, I want you to type this exact thing into your calculator. To find the hypotenuse, that's Pythagoras' theorem, you told me. So you're going to tell me the square root of the horizontal plus the vertical squared. So type that, square root of x squared plus y squared. Don't type the numbers, type the x and the y. What does that tell you? Yeah, sure. 513.536. 536. Okay. So that's the length of this vector. It's traveling left and up, but the distance that you traveled, so when ground control needs to decide how much fuel to put in the plane, they'll have to put, slightly more than that, plus obviously some emergency. But like they'll have to calculate. They don't want to be carrying too much fuel because that's extra weight, extra heavy. It's extra. It's not right. So they base that. So now we also need to know this angle where we are from there. So that is opposite over adjacent. So I want you to type in inverse tangent of y divided by x. Not the numbers, the actual characters y and x. What does it say? Okay, negative 19 what? 907. 908. Okay. All right. So now it's time to be smarter than the calculator. We're going left and up. Is there any way that can be negative 19 degrees? No, absolutely not. So what do we add to that? Add 180. So that give us what, like 161, 60.0. That. Okay. And that's it. Right? So you'll get so good at it, you'll just be able to do it, But I do advise on testing situations, you write it out, draw it out. Like on all the practice, check the keys to make sure you're getting the right answers. At some point when we assess, the ones that you assess on will be the ones we've practiced. So you'll have something from what we've done. All right. I won't tell you which one it is, obviously, but all right. So today's lesson, today's practice is going to be doing number 19 and 20 from Friday's worksheet. So if you were absent Friday or whatever, it's on here. But it should be anything. Yeah, 19 and 20. So if you did do it with triangles, go ahead and redo it with vectors, please, just for practice. All right? Questions for the good? Yes, what's up? Oh, pretty. Yes, you can. Can I stop? Let me stop the video then. You're good. Sorry. I just, for the good means for the helping of people that are... Oh, hang on a second.
So, we were trying to find this, right?